Hey, we're now joined by Greg Becker and Todd Gamblin from Lawrence Livermore, who represent the open source Spack projects. Hey, everybody.
Thanks.
And they're going to talk to you about the skills that you need this week in order to make great use of Spack as part of the hackathon. I'll leave it over to you guys now.
Okay, great. Can we share the slides, Brendan? Great. Okay, so you're going to be using Spack as part of the tutorial. There's a lot of online help on Spack, so we just wanted to point you to that first. You can get the full documentation here. This is reference docs, so if you're reasonably familiar with Spack, it's a good place to look for just all the details you need. There's a tutorial here if you want to just go through some basic exercises. Greg is going to do a little microcosm of this tutorial later in this short. And there's also a Slack instance just for Spack. So if you have detailed Spack questions, you can go here and maybe get more help in addition to the hackathon Slack. But we'll also be in the hackathon Slack answering questions. So either place is probably fine. Just to give you a flavor for what Spack does, we're using it for the tutorial because HPC codes are complicated. And let me go here. If you look at HPC codes, even a small one like MFEM is like 31 packages with 69 different dependency relationships. If you tried to build this finite element framework from scratch, it would take you a long time and you'd probably get it wrong a few times before you were able to build it. So we really want users to be able to just Spack install MFEM and have this thing work and have all the packages configured to work together. As you get into the AI regime, things get larger. So LBAN is Livermore's AI framework that sits on top of MPI. It's like 71 packages. And in the data analysis ecosystem, things get even bigger. So we have packages in Spack, like some of the R ones for genome data analysis, that are 179 plus packages. So things get pretty big. You would never want to install this yourself without a tool. Spack is different because it lets you, it violates some of the assumptions made by traditional package managers that really get in the way for HPC. So if you look at Conda, pip, APT, or systems like that, there's kind of a one-to-one relationship between source and binaries. You have source, you compile it, you build a portable binary, you stick it in your distribution, and people just use that and upgrade it over time. They try to make the binaries portable, which also means unoptimized. And there's generally just one tool chain for your typical Linux distro. And outside these boundaries, you're typically on your own, and that's why HPC builds tend to be hard. Spack is different. We want to build in lots of different environments. We recognize that HPC code is typically distributed as source so that you can build it fast on your machine. You want to build many different variants of the same package. So like for this hackathon, you're going to build lots of versions of the same thing. And they might be different. You want to compare them. You want to know that the version with one option enabled is faster than the version with another option enabled, and you don't want to have to go and reconfigure your whole system to do that. You want to optimize for the processor and the GPU because this can make a huge performance difference if you actually take advantage of the available hardware. And in many cases, you need to rely on system packages. So for example, the Spack that you're going to use for the hackathon is configured to use the system MPI that's optimized for AWS's parallel cluster. Spack lets you leverage that in addition to building your own packages. Finally, HPC codes aren't just one thing. So things like language package managers are typically not enough to build something fast. You want to be able to build things in C, C++, Fortran, Python, lots of different languages in the same build. And if you look at what we care about, at least in the DOE, there are tons of architectures that we care about. There's Power9, ARM, Intel, AMD systems, and they have 3 different GPUs. And ARM has SVE on, for example, Fugaku. We're not doing any of that for the tutorial today. We're focusing on ARM, but again, it's an exercise in porting to a new platform and optimizing it. And that's what Spack was made for. It's designed to run across all these diverse machines. So it enables software distribution for HPC. It lets you build a recipe for your package so that someone else can go and install it easily. If you weren't using a pre-configured Spack, you could just clone it from the Git repo like this. And we have a simple syntax that lets you do complicated installs. So you can set the version of the thing that you want to install. You can set what compiler you want to build with. Lots of the packages have options built in. You can inject flags in your build, set the target for the target microarchitecture. So for this one, we're going to be using Graviton 2. And you can control what MPI you're using. Here we have it pre-configured for the hackathon. But this gives you an idea. Spack is configurable. You want to be able to build for lots of different sorts of targets. It can generate modules, so it makes HPC cluster admins. It makes it easier for them to install your package once you've Spackified it. And that means that more people can put your package on their cluster. That's what we're trying to do here. We want people to be able to put all these pieces of software on ARM clusters. It lets people set up different environments for different projects, so it helps developers. And we have DevOps features like CI and so on that you can use with Spack. You'll see that during the tutorial. Spack has a growing community. It's used worldwide. And this is our contributions to packages over time. So these are years since we started in 2013. We started getting lots of contributions in 2016, and it's been ticking up in the past year. We'd love to see this number increase with all of your contributions to Spack packages. So get those pull requests in, and we'd like to. We'll help you out. We'll help you get them submitted. All right. So I think that's all I've got for this. Greg is going to do a demo of some of the basic things that you probably ought to know about Spack before getting started. So I'm going to hand it over to Greg.
All right. So this demo is going to be based on part of the Spack tutorial from the developer workflow section, and is going to be focused on how to debug when things go wrong in Spack. So give me a second and I'll get my screen shared, and then we'll go ahead. Here we are in my terminal. And we've got a Docker container that I pulled down with the Spack tutorial setup in it. This will just have some pre-built binaries that we'll use. And in this image, I've just cloned Spack, and I've run some setup commands. This is kind of a pre-configured Spack instance like what you'll see in your hackathon. And here we'll make a Spack environment. So we will make a directory for it and create a local environment here. We'll activate that environment. And now you can configure all sorts of things in your environments. You can manually edit your configuration, but you can also just pop configurations options in from the command line. In this case, we'll configure Spack to turn off the Fortran variant for anything that has an option for whether to use Fortran or not. And then we'll add a package. Maxio is an I/O proxy app. This is what we'll be developing in this example. And we can say Spack install. And everything needed for Maxio built with SCR is going to be installed.
And we're installing from binary here in the in the demo, but you'll be building from source.
Yep. The first time you run Spack, it's a little slow as it develops some internal caches, but this should plug through this in just a second. So here, as we scroll through the output, we can see Spack has concretized, determined what it needs to install. You can see a tree representation of that here. We've started pulling binaries. We built PatchElf to be able to relocate the binaries. And now we're unpacking binaries from the source mirror, or from the binary mirror. So as we go through the dependencies, right, we can see all sorts of low-level system libraries getting installed, making sure that we have appropriate versions for all of them. Build tools like M4, and also more complicated packages like Perl. You can go down a whole rabbit hole of trying to figure out how to install Perl yourself if you feel like it.
Ooh, all right, we're up in the HPC dependencies now. We hit Silo and Lightweight Group Library.
Yeah, and here we are at Maxio itself.
Awesome.
And now it's updating the view associated with this environment.
All right, so how do they see what's in the environment?
So if you want to see what's installed, you can say Spack find. Here you get everything that's installed, but also Here are the roots, the things you requested. And if you want to look at the view associated with the environment, if you look in .spackend/view, you can see everything's been linked in here. You can see the bin directory with all the SCR commands in there. And you can see that that view has actually been added to our path when we activated the environment. So let's say there's a problem with SCR and we need to actually patch it to get it to work. We could say spec develop SCR at 2.0.0 and we can see if we do spec config get, we can see our environment and we've configured SCR as something to develop.
And that's just in the spec.yaml right here, right?
Yep, that's just in the spec.yaml file right here. And we can see we've also downloaded the source code for SCR at version 2.0. And we can actually edit a file in there.
SCR/source/SCR, right? Yep. Just to be crazy in the demo.
Yep. SCR/src/scr.c. And we can imagine making a mistake here.
It's just delete
which I mean just deleting the last semicolon. And if we run Spack install again, Spack concretize -f first, force it to reconcretize SCR.
And then you're going to build, once that's done, you're building from that source directory. You just check that.
Yeah.
Right?
So once we reconcretize, you can see this dev path is set. That means Spack knows that it's building this from a local source. And if we Spack install again, Spack will notice that the source has changed since the last build, and it'll go and rebuild SCR and rebuild the things that depend on it. Now, in this case, it won't rebuild the things that depend on it because SCR failed. That's what we would expect. We removed the last semicolon. And we know how to fix that since we just removed a semicolon. But if we wanted to debug it further, we can say Spack build env SCR and get a subshell in the build environment. And look at the Spack compiler, etc. In this build environment. We can cd to SCR, run make in the build environment.
One directory deeper, right? It's under source. Nope.
Nope.
Oh no, it's up in the CMake directory, right? Or isn't there a separate build directory for this? Yeah, Spack build.
Yeah, here we go.
Yeah. It made the CMake out of source directory there. Yep.
So we can run make in here, and we can get all of the errors that we would expect from having deleted that semicolon at the beginning. And we can do our we can do our debugging in here. Eventually we figure out it's the semicolon we deleted. We can exit this subshell and fix our file again. Return our semicolon in this case. Maybe you've actually patched something that matters for getting this to build on ARM. And now we can Spack install again. And again, Spack will see that the source code for SCR has changed, and it'll make sure to rebuild.
So you just checked out like 40 libraries and then checked out the source for one and tweaked it, and you were able to build that with the whole stack, right?
Yep. So here we've rebuilt Maxio.
Yep.
With our new SCR that we've patched. And if this was a fix for SCR, in the end, we could go and try to upstream this to SCR, or we could stick in a patch file in our Spack package. So if we Spack edit SCR, we can also
do the actual package.
This is the Spack package. This is how Spack knows how to build it. So if we had a patch that we hadn't been able to upstream, we could define a patch method here, and you could say remove that same semicolon.
Other way around, right? Oh, I see. You're patching it to make the break.
Yep.
Yeah.
And this is just a little simple patch right here. And now we can Spack undevelop SCR, right? We've added the patch to the Spack file. And then we can Spack concretize -f again.
That tells it to use the built package and not the source, right?
Yeah. So this is telling it to say, okay, we need to reconcretize because we've changed what we want in our environment, and now we're not going to build from source anymore, or from local source anymore. We're going to do the normal Spack build of SCR, and then we can say Spack install. Uninstall -f SCR because we have this old version without the patch that was installed. I'll uninstall the thing that depends on it as well. And now we Spack install here.
Oop. Concretize -f will get rid of that bug. Sorry about that.
No,
Nope.
it won't. Oh, gracious.
You got a lowercase d in there.
Wait, know how I did that. So now I've set my editor
To
so
something
I
you
can
can
edit
use.
the file and something I can actually use. And that doesn't look like it has any problems.
Do a Spack-D install to show the stack trace.
Oh. When we uninstalled Maxio plus SCR, it removed it from our environment.
Yes.
So we're trying to install 0 specs.
That's not the greatest error message for that. We should patch that.
And now we can install.
There we go. And now it'll patch it with your bug, right?
That ran from source.
Yeah. Okay.
So we will actually install without allowing ourselves to use the cache.
Users won't have to deal with that in their environment. Yeah, okay. So it patched it and now it has the same bug.
And now we've successfully patched the SCR package to fail.
Is Emacs just being slow?
Yep.
Yeah, there we go.
And if we go back to our patch, can make our patch even sillier. And we can
undo the change.
we can make the change and unmake the change, right? So this should now work. And Spack install with no cache again.
Yep,
and so now SCR is built from source. MaxIO has built from source. No problems there. And now, if we cd to our Spack directory, you can see we've, well, in this case, we've created a really silly patch, but if we're actually debugging a problem, here we've created a patch to Spack that will allow us to work around this bug in SCR. And we can now both contribute the bug fix back to SCR if that's an open source project. In this case, it is. And we can contribute this patch back to Spack to say, hey, here's how to work around this problem before the patch gets upstreamed.
So why don't you
that's
package again and show them the install method in some of those parts, so they know where to look for to change the recipe.
Yeah. So that's this is how you would go about debugging problems in Spack. If we look more closely at the SCR package, just as an example of a package, you can see it's a CMake package, so it's going to be using CMake. We can see all the dependencies, so you might need to add constraints on some of these dependencies, depending on what's in the package. You can see we've got optional dependencies here, different options. We might need different options available for ARM. And then here's the actual magic in the CMake args method. So for CMake, there's an implicit install method, and it takes argument, and it runs CMake, make install, and there's it takes the arguments from this CMake args method. So here we construct all of the options that are necessary to get it to run, and you can see there are options specific for different types of machines, for different dependencies, for different variants that you can.
How would you put in a condition for if the target's ARM?
I'm getting there.
Yeah. Okay.
So different options. We've got some commented out. So apparently someone ran into a problem but left the code in when they removed it. So maybe we'll need some specific options for ARM later. You could say if the spec satisfies target equals arch64:. And so that just means if Spack is targeting an architecture that's based on arch64, so any of the Graviton, A64FX, ThunderX2, anything like that will satisfy this spec. This is like our version argument, you know, this or later. And then we can say no, we don't have anything specific to do right now.
You could append a special argument or something, like the other ones.
Yeah, so args.append.
The ARM stuff.
Package might have its own options for ARM that we need to throw. And then we could reinstall this. I'm actually running on an x86 machine right now, so I can't really demonstrate this. But on an ARM machine, right, this option will get appended. If we want to look at what we did, I'm just going to undo these changes real quick. We can Spack cd-i scr, and in the .spack directory, we can look at the build output, and we can see here's the CMake line that was run. And you can see all these options from the CMakeArgs method that were being set.
That's
Here
the
they
whole
all are.
configure line.
Here they all are. And so all the way down to here, you can see, we turned off Fortran in our configuration. The Spack package respected that and passed the enable Fortran equals false option, for example. And you can see a lot of the dependencies paths show up here as well. Yogurt prefix, PDSH prefix, etc. Then we've also got all the output. So you can look in here, see if something went wrong. Here's where the config file is going to be. And then further down, you've got all of the build output, some warnings. You can look at those and see if they're actually scary warnings or just compiler warnings that happen from time to time. If we scroll all the way down, we can see it installing the files from the build space into the install space. And those files are all right here in the install prefix. Here's all the SCR commands. And we can CD back to where we were. Those same files, of course, are all in our development environment. Backend are all in the view. But here, we're actually symlinks back to the install prefix that we were just looking at. So we can see here's the SCR command, and it's pointing back at SCR. So I think that's a pretty good first primer on how to debug Spack packages, whether the error comes from the package or the Spack recipe for that package.
Can you show them where the packages live and how to grep?
Yeah. So if we
helpful things for them to look at is you could, if you want to see how other folks did ARM patches, you can just look at the 5,000 other packages in Spack.
Yeah. So if we CD back to the Spack directory, if we Spack edit SCR, we can see this is actually coming just from var Spack repo's built-in packages. This is just the built-in repo for Spack. And we can look at that. And we can see directory for every package in Spack.
You can actually do Spack CD-P to get there.
Yes, we can. So if we want to see how other packages have handled things for ARM, we can do a git grep arch64 in or if you don't want to remember that, Spack location of all the packages. And we can see all the different things people have done for ARM. A lot of patches.
Various conditions.
Some conditions. Some things say they just don't build for ARM. You can see the conflicts, things that don't build, or early versions don't build. And so this can be a good place to look for examples of how to do things for ARM. There's a lot of packages, though. It can be a bit of a fire hose. And git grep has turned my terminal red for some reason.
Oh, just type reset. That's weird.
But anyway, that's probably the best place to look beyond the Spack documentation for anything about Spack packaging. Just look at the 5,000 or so examples that are already there, and they should give you a good idea how to do it.
I think that's pretty much it. And we'll be online during the hackathon to help you out. You can ask us questions, and we can send you pointers to some of these places. So fire away.
Hey, thanks for that. We're going to go to Q&A now, right after this session. The Q&A will be conducted in the Help Spack channel on our Slack instance for the event. So, and you'll be able to catch up with Greg and Todd and Christian and Austin and Ollie and all of the other Spack fans that we have that are staffing the event and covering the help areas. Todd, Greg, thank you. That was awesome.